Okay, did you work on these before you found the answer key video? Wonderful. And if you're like, not really, I kind of want to work them with you, that's great. I don't have a challenge with that. All I ask you to do is pause the video at certain points and try to do some of the work on your own, okay? And if for example, you got number 1, then fast forward to number 2. But here we go with number 1. And I'm only going to work one of these out at a time. I want to make certain I have enough board space to adequately show how we get the result. Are we cool? Okay. So they asked me to divide. They asked me to use long division. But I need to recognize why I'm using long division. This is a division problem. Notice the denominator. How many terms does it have? 2. Because it has 2 terms, remember, terms are separated by addition or subtraction. Because it has 2 terms, this is super glued together, which does not allow me to actually figure out easily what the fractions were that gave me this answer. So I have to use long division when the denominator has 2 or more terms. So here we go. Which one goes underneath, the numerator or the denominator? Good, the numerator goes underneath the division symbol. So we have x to the 4th minus x cubed plus 10x minus 4. Gratefully, it's in descending order, and gratefully oh wait, I have a missing term, don't I? Oh, what am I missing? I'm missing an x squared. Okay, so here's the deal. Here's what I'm going to recommend. Some of you don't need this, because technically this step is optional, and some of you do need it. I have how many x squareds in the original problem? None. In math, none is represented by what number? 0. So I have 0x squared plus 10x minus 4. My recommendation is you put the placeholder in. Okay? All right. And on the outside is the x plus 2. Now, don't look at the whole thing, a piece at a time. Remember what you're trying to do. You're trying to systematically wipe out every term underneath the division sign. You start with the first term, and the first term gets wiped out by the first term. So you could ask yourself, how many times does x go into x to the 4th? Or a better question is, what's this x missing to look like this one? Technically, there's only one of them here, and how many are there? 4. So I'm missing 3 x's. Remember, once you put a term up top, a number up top, you multiply by what's on the outside. So I'm going to take x cubed, and I'm going to multiply by what's on the outside, and that gives me x to the 4th plus 2x cubed. Agreed? And then I'm going to take that and put it under the like terms. So x to the 4th under x to the 4th, x cubed under x cubed. Got it. And then what do? I subtract. How many times again in this case? Twice. Not only are you subtracting off the x to the 4th, but you're also subtracting off the 2x cubed. Good. Now what happens? Yay, they canceled. That was the goal. And now I have a negative x cubed minus 2x cubed. That will give you minus 3x cubed. And then what do you do in long division after you subtract? You bring down the next term, right? My recommendation is you bring them all down. Sometimes I need this one before I need this one. Sometimes. It depends upon what I'm dividing by. So I think it's a good habit to get into by just writing them all down. And then we get to start over, don't we? So now this is the first term. And what is it missing? What is this x missing to look like a negative 3x cubed? You're like, it's missing a negative 3. That's true. What else? And 2 more x's. How many are here? 1. How many are here? 3. It's missing 2 more x's. Good? So once you put the term up top, what do? We multiply by the outside. So let's see what we get. Negative 3x cubed minus 6x squared. And you put those under the like terms. So negative 3x cubed minus 6x squared. Then what do? You subtract. How many times? Twice. You're going to subtract off this negative. Yeah, that makes it a positive. You're going to subtract off this negative. Yeah, that makes it a positive. So what happens? First term wipes out, which is exactly what we wanted. Yay! And then we end up with a positive 6x squared, a plus 10x, and a minus 4. Because remember, bring the rest of them down. And then we start all over, don't we? Getting the hang of this? All right, let's see. So 6x squared is now the first term to wipe out, and I'm using this x. So what's the x missing? It's missing a positive 6. What else? And one more x. And then what do you do after you put the positive 6x on top? You multiply it by what's on the outside, and you get 6x squared plus 12x. What do you do with these two terms? You put them under the like terms. Good. So I've got 6x squared plus 12x. Then what do? You subtract. Wonderful. How many times? Twice in this case. Minusing off the 6x squared and minusing off the 12x. So the 6x squareds cancel. That's the goal. Woohoo! And what's 10x minus 12x? A negative 2x. And then, well, there's only one term left to bring down, the minus 4. Done? You're right, we're not. Because this is a first degree. This is a first degree. I can keep going. So what's this x missing to look like a negative 2x? A negative 2. So once you put the negative 2 on top, multiply by the outside. I personally like to write these down. You know, we move too quickly, we could mess something up, don't want to do that. It takes 2 seconds to write it down and multiply. So a negative 2x and a minus 4. What do you do with these? Put them under the like terms. Then what do? Don't skip this last part, because some of you are like, oh, I see, I'm done. Don't skip it. What do? You subtract. So that becomes positive. That becomes positive. First term wipes out. Woohoo! Hey, this wipes out also. That's bonus. That's gravy, shall I say. With me? Okay. Never skip this last step. Because if this sign is not correct, you might have ended up with an 8 versus a 0. So don't skip that last step. Just do it. Make sure you write a 0 down if that's what you really get. Okay. So this 4th degree polynomial divided by this 1st degree polynomial gives us x cubed minus 3x squared plus 6x minus 2 without a remainder. It went in evenly. Good? Okay, problem number 2 coming your way. Okay, are you getting the hang of it? Did you do this one yet? Pause the video and at least get it started if you haven't done it, and then resume. Okay, I'm assuming you started it at least. So we have a division problem. This 4th degree polynomial divided by this 1st degree polynomial. What degree polynomial should be our answer? You have a 4th degree divided by a 1st degree. It's cutting it down, right? 3rd degree. If you do 4 minus that 1, we better get a 3rd degree polynomial as an answer. At least that much I know. If I don't have a 3rd degree, I did something wrong. Good? Okay, so how many terms are in the denominator? 2, which makes us do the long division. Okay, which one's underneath? The numerator. 2x to the 4th minus 3x cubed minus 11x squared minus 40x minus 1. It looks like all the terms are here this time. I don't have anything missing, so that's great. So on the outside is the x minus 4, right? Okay, tell me how you get started. Trying to wipe out the first term of 2x cubed using the first term of x on the outside. So what's this one missing? It's missing a 2 and an x to the power of 3. Got it. And there's our third degree polynomial answer, at least the start of it. So what do you do when you put that up top? You multiply by what's on the outside. So you have 2x cubed times x minus 4. So what do we get? 2x to the fourth minus 8x cubed. What do you do with these? Put them under the like terms. So 2x to the fourth minus 8x cubed. And then what do? We subtract. How many times? Twice. Subtract off the 2x to the fourth, and I'm subtracting off a negative, which makes it positive. Got it. Now what? So the first term drops out, exactly what was supposed to happen. And now I have a negative 3x cubed plus 8x cubed, which gives me a positive 5x cubed, doesn't it? Then what? It's only division, so you bring down the next term, right? But remember, my recommendation was bring them all down because you never know. Depending upon what's out here, I might need that term before I use the second degree. I might need the first degree before the second degree. You never know. Okay, now what? Start all over again. What are we trying to wipe out? The 5x cubed, using the x on the outside. So we're missing a positive 5 and an x squared. And now take that 5x squared and multiply by the x minus 4. I'm getting it. Are you getting it? Okay, so 5x to the third minus 20x squared. Got it. What do you do with these two terms? Put them under the like terms over here. So x cubed under x cubed, x squared under x squared. Now what? Now you subtract. Understood? So how many times? Twice. So this is minus, and this becomes positive. Very good, because you're subtracting a negative. First term drops out, exactly what was supposed to happen. Negative 11x squared plus 20x squared is a positive 9x squared. Good. Then what? Bring the rest of them down. Start all over again, right? Okay, what did you put on top then? A positive 9x. Good. Then you took that positive 9x and you multiplied by x minus 4. Got it. What did it give you? 9x squared minus 36x. Understood. What'd you do with it? These two terms? Put them under the like terms. So we have 9x squared under 9x squared and a minus 36x under negative 40x. Now, subtract twice. So this is a minus 9x squared, and right, that's a positive because you're subtracting a negative. Agreed? Yay, first term is dropping out. We're doing something right because the first term keeps dropping out, so that's great. So you have a negative 40x and a positive 36x. Gives you a minus 4x. Bring down the 1. Got it. Now, are we done? Nope. First degree, first degree. Both those x's are to the power of 1. We're not done. So what'd you write up top then? Yeah, it's missing a minus 4, isn't it? It's missing a negative 4. Then what'd you do? Then you multiplied by what's on the outside. So this is what I got. Is that what you got? Then what? Write it underneath the like terms. And then, yeah, I heard you. Some of you said change the signs. Basically, that's what you're doing when you multiply by a negative, aren't you? So this drops. That leaves you what? A negative 17. Are we done yet? Yes, we are. Because how many x's are there? 0. This to the power of 1. Technically, this negative 17 with 0 x's is smaller than this binomial on the outside, which has a power of 1. So remember, what were you trying to do? You were trying to take the 17 and divide it by x minus 4. And oh yeah, that's a negative 17. So the result, of taking this fourth degree polynomial, dividing by the first degree. The result was 2x to the third plus 5x squared plus 9x minus 4 minus 17 divided by x minus 4. Here is your result. And as we said, we should have gotten a third degree polynomial, and gratefully we did. Good? Okay, got another problem coming your way, so stay tuned. Hey there, you getting the hang of this? Not too bad, right? As long as you understand that you're trying to wipe out the first term underneath the division sign by the first term on the outside, and you let everything just kind of follow along, tag along, it's not too bad, is it? Okay, so you're dividing by two terms, which means use long division. So here we go. And by now you know that the numerator is always underneath. So I have 12a cubed, and I need to make certain it's in descending order. So far, so good, and it doesn't look like I'm missing any terms. Third degree, second degree, first degree, and then 0 a's. And 4a plus 1 on the outside. Okay, so now what? First term and first term. So, what's the first term on the outside missing to look like the first term on the inside? Remember, you're multiplying. So what would you multiply by the 4 to get a 12? You would multiply by a 3. And there's how many a's on the outside? 1. How many a's on the inside? 3, which means 2 more. So I put 3a squared over the a squared term. Like term over like term under like term. Good? Okay, you just put that up top. Now what? Multiply by what's on the outside. So what did you get? 12a cubed plus 3a squared. Put like terms under like terms. 12a cubed plus 3a squared. By the way, let me stop a moment. You start with the third degree and you're dividing by a first degree. The resulting polynomial should be to what power? You're dividing, you're cutting it down. A third degree gets cut down by a first degree. You got a second degree, which is exactly what we should have gotten. Okay, so we multiplied, we put like terms under like terms, and now subtract. How many times? Twice. So subtract the 12a cubed and subtract the 3a squared. Good. Now what? Yay, first term drops out. Woohoo! 11a squared minus 3a squared. 8a squared. And then bring down the rest of the terms. You never know. So far we've just been using them in order, but you never know. Now what? Start all over again. Okay, so I need this 4a squared to look like this this 4a to the power of 1 to look like this 8a squared. What do you got to do? You got to multiply by a positive 2. And you're right, we need another a because there's only 1 here and there's 2 there. Great. Now what? Take the 2a, multiply by what's on the outside. Okay, I'm with you. What'd you get? 8a squared plus 2a. Understood. Put them under the like terms. Okay, I'm with you. Then what? You're going to subtract how many times? Twice. Okay, so we're subtracting 8a squared and the 2a. Okay, so yay for this. You see it as well as I do. This drops out, and this becomes 16a, and you bring down the plus 9. Got it. Now, all over again. You start all over again. What'd you put up top? Good, a positive 4. I agree, because you need to multiply the 4 by 4 to get 16. And this only has 1a, and this only has 1a, so you don't need any more a's. So then 4 times what's on the outside. 16a plus 4. Got it. Under like terms. Then what? Subtract. Understood. The first term drops out. Wonderful. That's what's supposed to happen. And you're left with a 5. Is that the remainder? Yes? How do you know? 0 A's with the 5. There's 1 A with that 4. This is technically bigger. So you have a remainder, don't you? And it's a positive 5. So plus 5 divided by 4A plus 1. Because technically that's what you're still trying to do. You're trying to take the 5 and divide by 4A plus 1. It's just not working. Okay, third degree polynomial divided by this first degree polynomial. What's your result? 3A squared plus 2A plus 4 plus 5 divided by 4A plus 1. You're right. That is your result. Good job, you guys. Well done. Making sense? Okay. These next two examples are just a little different, but it's not a big deal because gratefully the process doesn't change. Stay tuned. Okay, problem number 4. Did you try it on your own? You tried? Yes. How'd you do? Comme ci, comme ça? All right, let's check it out. So, how many terms in the denominator? 2, which means, yes, you're going to have to do long division, not a choice. Answer me this. I have a 4th degree on the top. I'm dividing by a 2nd degree on the bottom. The resulting polynomial should be what degree? Should be a 2nd. So here we go. So the numerator goes underneath, x to the 4th, but I'm missing some terms, aren't I? So I put in placeholders just in case I need them. I may not need them, but just in case I do, they're here. I'm missing an x to the 3rd. I'm missing an x to the 1st power, and then minus 8. And if I don't need them, 2 seconds of putting comfort in, shall I say, is not a bad thing to do. Okay, so first term on the inside to wipe out by using the first term on the outside. What'd you put on top? X squared, good, because we're missing 2 x's. And I put x squared over x squared, then what? Multiplied by what's on the outside, so x squared times x squared minus 2, what'd you get? X to the 4th minus 2x squared. So like terms under like terms, x to the 4th under x to the 4th, and minus 2x squared under 2x squared. Now what? Subtract. So this is minus x to the 4th, and that's plus. Good. X to the 4th drops out, which is exactly what was supposed to happen. I'm bypassing x to the 3rd because I didn't put anything under it, did I? So I'm just going to bypass it completely. If I'm not using it, I'm not using it. This is 4x squared. Carry down the rest, you never know. Now what? Start all over again. 4x squared needs to be wiped out. I'm missing a plus 4. X squared is the same as x squared, not missing any x's. So 4 times x squared minus 2. That's right, 4x squared minus 8. Then, like terms, under like terms. Then what? Subtract. Remember what I said, don't skip this step. Because if this sign is off, you don't get what you thought you'd get. First term wipes out, and so does the last one. That's gravy. So, I guess it went in evenly, didn't it? This 4th degree polynomial divided by that 2nd degree polynomial gives us x squared plus 4. Cool. I have one more example coming your way. If you haven't done it yet, try it. Stay tuned. Okay, how'd you do? You did good? Excellent. So let me do the work and see if we match. Okay, there's a 6th degree polynomial up top. I'm dividing by a 2nd degree. I'd better get a 4th degree as an answer, right? Okay. And in the numerator, I've got a lot of missing terms. Well, I don't know what I'm going to need. I don't know what I'm not going to need. So I am going to write down all my missing terms. I might need some more board space. I might need to use a thinner marker. but it looks like I can squeeze in the minus 27. Just barely, right? Okay. Okay, here we go. So let me see. 4 times what is 64? That's 16. 2x's here, 6x's here. I need 4 more. So I need a 16x to the power of 4. And then I'm going to take that, check my work, make sure I'm doing it right. I'm going to multiply by what's on the outside. So that's 64x to the power of 6 minus 48x to the power of 4. And I put it under like terms. So 64x to the 6th, and then negative 48x to the 4th. And then I'm going to subtract. So this becomes subtraction. This actually becomes addition. My first term drops out. Good. Didn't use x to the 5th. Don't care about it. Here I end up with 48x to the 4th. And then I'm going to write down all the terms that follow. Maybe I need them. Maybe I don't. Okay. Did I agree with you? Great. All right. So let me think. I need a 4 to look like a 48. So what is that? Times 12. Okay. So I know I need a positive 12. And I need 2 more x's. Yes? Okay. So I'm going to take 12x squared multiplied by 4x squared minus 3. So I get 48x to the 4th minus 36x squared. Yes? Like terms under like terms. 48x to the 4th minus 36x squared. And then I decided to subtract. Well, that's the process, right? So subtract this one and add that because minusing a negative. Gratefully, the first term drops out. And I get 36x squared. I don't care about x cubed because I bypassed it. And I'm writing down everything that follows. Okay, let's see. Start again. So I need a positive 9. And I don't need any x's because I have an x squared and an x squared. So let me do my multiplication. So 36x squared minus 27. Like terms under like terms. And then I get to subtract. So this becomes subtraction. This becomes addition. First term drops out. I end up with a 0. It went in evenly. Yay! Did you get that? High five. Okay, so this sixth degree divided by the second degree gave me 16x to the 4th plus 12x squared plus 9. Good? This was a good problem. You had a lot of missing terms. Not a bad idea to write them all out like I did, and they just kind of drop away if you don't need them. Go back, rewind, review as needed. As I said, dividing by polynomials I think is easier than dividing numbers because I don't have to guess how many times a number goes into a number. I'm just looking for what's missing. Okay, have fun. Catch you on the flip side.